Hey guys, welcome to the Pre-Calc Unit 5 review video key on matrices. Let's jump right into it here. Calculator inactive, solve the following using algebra. That means using equations. So remember, the first thing I'd like you to do is number the equations. All right, it makes it easier for me to see your thought process and also for you to keep your work organized. At first glance, you might want to take equations 1 and 2 and cancel the x's. You certainly could do that. What that would do is it would leave you with a yz equation. But this is not a yz equation, so you'd have to somehow use this with either 2 or 1 to get another yz equation. Since this equation does not have a z, I'm going to pick 1 and 2 to cancel the z's. All right, so I'd need a negative 2 times equation 1. All right, and what's that going to give me? Negative 2x minus 2y minus 2z equals negative 4. Don't forget to multiply the other side. I'm going to take that and combine it with equation 2. Negative x plus 3y plus 2z equals 8. So now negative 2x and negative x, that gives me a negative 3x. That gives me plus y. Z's cancel, and I get a positive 4. So this is equation 4. Notice I have an xy equation here. I have an xy equation here. And what's nice, I've got a y and a y, so I just need to negate one of the equations. It doesn't matter. I'm actually going to bring down equation 3. I'll negate that one, and that's going to be negative 4x minus y equals negative 4. All right, so combining these, negative 3x, negative 4x is a negative 7x. The y's cancel, and that gives me a 0. Now, this doesn't mean anything weird. This just means x equals 0, right? It's not a no solution or infinite solutions. Don't get confused there. Negative 7x equals 0. You divide by negative 7, x is 0. So now what's nice about this, once you have x, you can plug it into any equation. I'll take equation 3 here and do 4 times 0 plus y equals 4. That's pretty easy. Y equals 4. And now once you know x and y, you can pick any equation. I'm going to pick the top one and get z. X is 0, y is 4, plus z equals 2. Subtract 4, z equals negative 2. All right, so that's totally fine. You could just leave it like that. If you want to write it as an ordered triple, 0, 4, negative 2. You certainly do not have to do both. All right, moving on to matrices, matrix operations. Remember here, to add, you must have like dimensions in order to add, okay? So if I want to add d plus e, all right, d is a 3 by 2, and I want to add e, which is a 2 by 3. Clearly those are not like dimensions, so you can't do it. Just indicate that you can't do it. Don't just leave it blank. Question 3, you're multiplying by a scalar. This is pretty simple. I'm taking matrix F. I'm going to multiply the whole thing by negative 3, so it's just like distributing. And I don't really need to show a lot of work for that. Just make sure you distribute that negative 3. So I have negative 3 times 2 is negative 6. Negative 3 times negative 3 is positive 9. Negative 3 times 1 is negative 3. Negative 3 times negative 6 is 18. Negative 3 times 9 is negative 27. Negative 3 times negative 2 is positive 6. Negative 3 times negative 3 is positive 9. Negative 3 times 5 is negative 15. Negative 3 times a negative 1 is positive 3. Let me just double check my arithmetic. Yep, that looks good. Okay, moving on. So now, this is where it gets a little bit more challenging. Matrix multiplication, right? So I'm multiplying f times e. In order is very important. So the first thing you're going to do here is you're going to write down the dimensions of each matrix. So f is a 3 by 3. Now I want to multiply that by e, which is a 2 by 3. So remember, the test here, number of columns of the first matrix has to be equal to the number of rows of the second. Those are not equal. So if those are not equal, this can't be done. Okay, again, make sure you just indicate it, don't leave it blank. DE. I'm guessing this is going to work because the other one didn't, but D is a 3 by 2. E is a 2 by 3. So yes, this will work because those two are equal. My resulting matrix is going to be a 3 by 3. There's a little bit of writing here. Please, please, please write the original matrices out. All right, where I see issues every year, students try and just do it from the given matrices up above without writing them out. So D is going to be a 3, 1, negative 2, 2, 0, 5, times E, 1, negative 1, 2, 3, 0, negative 4. All right, I'm going to have a 3 by 3 matrix. I'm going to do all the work there, and then this will be my final answer. So the way this works is I take row times column. This is row 1, that's column 1, that's going to go here. Row 1, column 1. I'm going to combine those values and put that here. Okay, so I don't want to clutter up my work. I'm going to take this times this. 3 times 1 is 3. 1 times 3 is 3. 3 plus 3 is 6. So I know in row 1, column 1, I'm going to have a 6. So I'm just going to keep doing this. Row 1, column 2. Row 1, column 3. All right, so row 1, column 2, 3 times negative 1 is negative 3. 1 times 0 is 0. That's going to give me negative 3. Next, row 1, column 3. So that's going to be 3 times 2 plus 1 times negative 4. 3 times 2 is 6. 1 times negative 4 is negative 4. 6 minus 4 is 2. So there's that first row. Now we're going to repeat this process. Row 2, column 1, and that's going to go here. And that final result will go there. Negative 2 times 1 is negative 2. 2 times 3 is 6, and that gives me a 4. Okay, so now I'm doing this. Negative 2 times negative 1 is 2. 2 times 0 is a 0. That's a 2. Now I go row 2, column 3. Negative 2 times 2. 2 times negative 4. Negative 2 times 2 is negative 4. 2 times negative 4 is negative 8. A negative 4 and a negative 8 is a negative 12. On to the third row. This row times that column. So it's going to be 0 times 1 and 5 times 3. All right, 0 times 1 is 0. 5 times 3 is 15. So I got 15. Next, that row times this column. 0, 0. 5 times 0. So I get 2 zeros there. That's a 0. And the last one. Row 3, column 3, 0 times 5, 0 times 2, 5 times negative 4. So that's going to be a 0 and a negative 20, and that's negative 20. There is the final matrix. A lot of work, but be thorough, don't rush. Okay, next thing we have to do is find the inverse of a 2 by 2 matrix. You will have to do this without a calculator. It'll only be a 2 by 2, so we can kind of memorize the formula method for doing this, which is what I prefer. It's going to be 1 over the determinant times the matrix formed by taking this diagonal and flipping those values. So you switch them. Then you take this diagonal and you negate both of those. All right, so I like to write this out first. Switch the 2 and the 7. Negate the other diagonal. Okay, all it's left to do now is find the determinant, plug that in here, and then distribute that through. I'll do the determinant down below. Determinant, remember, is found by taking this product and subtracting that product. So I'll write it out here. It's going to be 2 times 7 minus negative 3 times 6. Just watch out for your negatives. This is Calc Inactive, remember. So I have 14 minus negative 18. That's 32. Okay, so I have to take 1 over 32 times this matrix. 7, 3, negative 6, 2. It's going to be messy, but who cares? I don't have to do anything with this matrix. You just distribute 1 over 32. So it's going to be 7 over 32, 3 over 32, negative 6 over 32, and 2 over 32. And I'm totally fine if you leave it like this. You do not have to simplify the fractions. If I were to use this on another matrix, it'd probably be easier, to be honest with you, to keep all the denominators the same. You don't have to, so it's totally up to you. All right, last one on this page, solve using the inverse matrix method. I want to take a second here to go over this. I noticed in class last week this is not done real well. Basically, here's a setup for an inverse matrix method. I have a matrix A, which represents the coefficients. So matrix A would be this matrix here, 3, 1, 2, 1, times my variable matrix, which for shorthand's sake, I'll just call X. The variable matrix in this case is going to be XY, equals a matrix B, which represents the matrix of your constants at the end. That would be matrix B. So in solving this, all right, what you need to do is you need to get this matrix over to the other side. We can't divide by matrices, so what we do is we move it over by multiplying by the inverse. So then your variable matrix is going to equal the inverse of your coefficient matrix times B, and that's going to be your solution. You can get your X, your Y, your Z if it's a 3-variable system. All right, so here's the setup. Here's what I'd like to see. Coefficient matrix, 3, 1, 2, 1, times variable matrix, X, Y, equals the constant matrix here, 23, 18. So now I need to move this to the other side by multiplying by the inverse. So the work I'm going to show, variable matrix, X, Y. I'm going to put the inverse matrix in there. You don't have to write this to the -1. I know it's going to be a lot of writing, but over on the side, we are going to calculate the inverse of this matrix. So over on the side somewhere, you can show this work. I don't have any room on the bottom, so I have to do it over here. So I need to take 3, 1, 2, 1, and find the inverse. Well, I just did it up above, right? It's going to be 1 over the determinant. So let's find the determinant here. It's simple. It's going to be 3 times 1 minus 2 times 1. I made it easy. 3 minus 2 is just 1. Okay, great. All we need to do then is interchange this diagonal and negate that one. All right, so 1, 3, -1, -2. That's actually going to be the inverse matrix. 1, -1, -2, 3. So now what we're going to do is we're going to multiply these two matrices. We just got done doing multiplication up above. You can see why we need to do it here. Row times column, that's going to go here. Row times column, that's going to go there. Okay, so 1 times 23 is 23. -1 times 18 is -18. 23 minus 18 is 5. -2 times 23 is -46. 3 times 18, I believe, is 54. -46 and a positive 54, that is 8. So what do we know? You don't just leave the matrix. X equals 5. Y equals 8. Okay, you could write that as an ordered pair as well, but you can see a significant amount of work for this. All right, next one, solve using Cramer's rule. Cramer's rule is very good. You have to do this with a 2-variable, and you're also going to have to do it with a 3-variable system. So Cramer's rule, basically, I want to find the determinant of the M matrix. The M matrix is the main or the coefficient matrix. So that's going to be 3, 1, 1, -2. And again, this is pretty easy. I'm going to show all the work. 3 times -2 minus 1 times 1. So that's -6 minus 1. I got -7. Again, that's the M. Now dx. How do you get the X matrix? Well, what you do is you take the constants and you replace the X column. So dx replaces the X column. All right, so that's going to be 13, 30. Then the Y column stays, 1, -2. All right, so this is going to be 13 times -2 minus 30 times 1. Let's see, 13 times -2 is -26 minus 30. So, wow, -56. All right, kind of a big number, but that's fine. dy. So now for dy, we are going to take the constants and replace the Y column. All right, so x's go back to the original x's. So that'd be 3, 1. but my y column now is 13, 30. All right, so I've got 3 times 30 minus 1 times 13. So what's that? 90 minus 13, 77. Okay. Now that we have the determinants, we need to remember that x equals dx over dm. Okay, so dx was negative 56 divided by negative 7. That is 8. There you go. Y equals dy over dm. So dy 77 over negative 7. That's negative 11. Again, you could write that as an ordered pair if you want. You don't have to. But that would also be acceptable. All right, calculator active. Now this is a little bit different than what you'll see on the exam, so I'll change a few of these. But this question right here would be calculator active for sure. Inverse matrix method with a 3-variable system. So let me show you the work you would need to replicate on the exam. Again, remember this. Basically, I take coefficient matrix times variable matrix equals the constant matrix. The variable matrix then equals the inverse of the coefficient matrix times the constant matrix. So you have to show this work, but using the numbers. All right? So here's what I want to see. Coefficient matrix. So there's no z in the first equation. It'd be 1, negative 1, 0. The second one doesn't have a y. So the y, the second one, would be 0. They're just trying to make it tricky here by having you fill in with zeros. And then the last one would be 6, negative 2, negative 3. So you have to show that matrix, that's coefficient matrix, times the variable matrix, x, y, z, equals the constant matrix at the end, 2, negative 4, 1. Okay? So now, all you have to do, so you can do the rest on the calculator. I can't show you the calculator work here. Please ask when you're in class if you have a question on this. You're going to show the variable matrix equals your coefficient matrix to the negative 1. All right, and it's just a little tiny notation, but obviously it's super important because this matrix here is not equal to this matrix. This is the inverse. So you're showing me you're going to be taking the inverse on the calculator. All right, and then you have to multiply that by the constant matrix here, 2, negative 4, 1. And that's the only work you're going to show. All right, so what you're going to do in the calculator is you're going to store this matrix here, actually this matrix here, in A. Right, it's going to be a 3 by 3. Put all those numbers in there. Then you're going to store this in matrix B. That's going to be a 3 by 1. You're going to put those numbers in. Then what you're going to do is you're going to go to your home screen. You're going to call up matrix A, second matrix, and you're going to hit the names. You're going to call up A. And then on your calculator, you're going to hit this x to the negative 1 key. And it's going to put this in there. It's going to calculate the inverse. I don't need to see the inverse. All right, could be messy, could be decimals. You don't need to rewrite it. The calculator is going to do that work. And then you can go back to second matrix. You can call it matrix B. So on your home screen, you're going to see this right here. A matrix to the negative 1 times the B matrix. All right, but this is the work I need to see on your paper. And then obviously the calculator will give you the answer. I have to check my calculator real quick. I got 9, 7, 13. So any way you want to express your answer from here, some of you will prefer just to go right to order triple. That's fine. Or if you prefer, you can do like x equals 9, y equals 7, z equals 13. I don't care how you write it, either or. All right, this question, collinear. If not, find the area of the triangle. This is actually going to be calc inactive on your exam. I don't know why it's calculator active here. Maybe the numbers end up being messy. I don't know, but we're going to do this assuming you cannot use the calculator, okay? So just remember that. On your exam, no calculator on this question. So how do we determine if points are collinear? Remember, we have to find the determinant, and if that's equal to 0, then yes. So I need to make a matrix using these points, 2, 6, 1, 4, negative 2, negative 2. Now, can you take the determinant of a 3 by 2 matrix? No, it's got to be a square matrix. So what do we do next? We fill in with 1s. Okay. Now, to find that determinant by hand, first thing we do, copy the first two columns. So this would be 2, 1, -2, 6, 4, -2. Now I can find the determinant. I'm going to start, and this is going to disappear, so maybe I'll have to circle them, but I don't want it to get too cluttered. Multiplying my downhill diagonals. So we always start with row 1, column 1. All right, I'm not going to circle them on this because, like I said, it might get too messy. So I have 2 times 4 times 1, that's 8. 6 times 1 times -2 is -12. 1 times 1 times -2 is -2. Minus. Now I multiply the uphill diagonals. Okay, so that's going to be -2 times 4 times 1 is -8. -2 times 1 times 2 is -4. 1 times 1 times 6 is 6. Combine those. So -4, I got -6 there. Minus, combine these, -12. That's -6 also. All right, so careful. Right, cancel those. I get 0. So, answer to the question. Yes, they are collinear because the determinant equals 0. Now, we didn't have to find the area because there is no area of a triangle, obviously, because the points are collinear. But if this is a non-zero number, remember, area of a triangle equals 1/2 the absolute value of the determinant. So you only have to do that if this is non-zero. Okay, last page. Solve using Cramer's rule. Again, this one's going to be messy. I know it's going to be messy because it's calc active, but on the exam, this would be calc inactive. All right. So we're going to do this assuming it's calc inactive. Find the determinant of the M matrix. So that's your coefficient matrix. 3, -5, 1, 7, 1, 0. There's no z. And notice in the next equation, there's no x. So 0, 4, -1. Copy the first two columns, 3, 7, 0, -5, 1, 4. And like I said, these numbers are going to get a little bit crazy, so I don't know if I'll be able to do this without a calculator. But remember the process. Start with the downhill diagonals. Multiply that stuff. Okay, so 3 times 1 times -1 is -3. 5 times 0, that's going to be a 0. 1 times 7 times 4, it's 28. Minus, now we do the uphill diagonals. So that's going to be 0. As soon as I see a 0, it's a 0. 4 times 0, that's going to be a 0. -1 times 7 times -5, that's going to be 35. So -3 and 28 is 25 minus 35, that's -10. I am confident in that result. So now I need to find dx. Remember, dx is going to be the matrix formed by replacing the x's with your constants. So that's going to go there. So 8, 4, 10. Now the y column stays the same, so I'm going to bring this down. And the z column stays the same, bring that down. So -5, 1, 4, 1, 0, -1. Copy the first column, copy the second column. These numbers look like they're going to get bigger. And I start with downhill diagonals. All right, so 8 times 1 times -1 is -8. -5 times 0, that's going to be 0. 1 times 4 times 4, it's 16. Minus, now I do the uphill diagonals, right, those products. 10 times 1 times 1 is 10. 4 times 0 is 0. -1 times 4 times -5 is 20. So that's going to give me 8 minus 30, -22. Yes, that is correct. All right, moving on. dy. So now in dy, I replace the y column with these constants. X's go back to the original x and z's stay the z's. Okay, so the original x here is 3, 7, 0. My new y column is 8, 4, 10, and the z's stay 1, 0, negative 1. Copy the first column, copy the second, and go ahead. So I'm going to start here, downhill diagonals, multiply those. 3 times 4 times negative 1 is negative 12. 8 times 0 is a 0. 1 times 7 times 10 is 70. Minus, now I do the uphill. So 0 times something, that's going to be a 0. 10 times 0, that's going to be a 0. Negative 1 times 7 times 8 is negative 56. Okay, numbers starting to get a little bit bigger here. So negative 12 and 70, 58. Minus a negative 56. 114. Yeah, wow, big numbers. I think this is the one that gets a little messy. On your exam, this question, even though it's going to be calc inactive, the numbers aren't going to be this big, so you don't have to worry about that. Okay, in this last one, I'm going to replace the z column with this right here, the 8, 4, 10. All right, so I'm going to write a little bit smaller. X's go back to the original x's, or stay original x's from above, 3, 7, 0. The y's go back to the original y's, negative 5, 1, 4. The z's are replaced with 8, 4, 10. 3, 7, 0, negative 5, 1, 4. Now I know what the final determinant is here, but I might get bogged down in some of these calculations. I haven't done this yet by hand, so we'll see. 3 times 1 times 10 is 30. Negative 5 times 4 is negative 20. Oh, it's a 0 at the end. 8 times 7 times 4. Yeah, so this is where it gets a little weird. 8 times 4 is 32 times 7. So that's going to be 210 and 14. 235 maybe? I guess I don't know. I'm just trying to do this in my head real quick here. Next, that's going to be a 0. That's going to be 16 times 3. That's going to be a really big number. So let's see. So I get a 0. 4 times 4 is 16. 16 times 3 is 48. 10 times 7 is 70 times negative 5 is negative 350. So this is where I'm not going to take a lot of time. I just know, looking at my answer key, that this is 556. So now, I've taken up all my room, but I need to get x, y, and z. So remember, x equals dx over dm. So dx is negative 22, dm is negative 10, and if this calc inactive, you can have fractional answers. That's what's kind of nice about Cramer's rule. I'll just leave this as 22/10. Call it a day. Y equals dy over dm. dy was 114, and dm is negative 10. So again, negative 114 over 10. There you go. That's good enough. And finally, z. I'll have to do z down here somewhere, I guess. Sorry. Z equals dz over dm. dz was at 556 over negative 10. And I don't really care where you put the negative, so that's fine. You just do it like that. So this is one advantage of Cramer's rule, is that if your answers are messy, so obviously these would all be decimals, right? 2.2, negative 11.4, negative 55.6. This would be a major pain to try and do with Gauss-Jordan. So that's why Cramer's rule is always going to be an option for you. All right, finally, we get to the last one. And this is definitely calc active. All right, I just want to note that. The real work to this one is setting it up. I want the equation of a parabola or a quadratic equation that contains those 3 points. So the first thing we need to do is understand the general formula. It's going to be y equals ax squared plus bx plus c. And I really need to put the y over on that side of the equation. So I prefer to think of it as ax squared plus bx plus c equals y. So now what we're going to do is we're going to take these coordinates here and plug them into x, y. I'm going to create 3 equations. My first equation is going to be using this point. All right, so if x is 2 and y is 1, this is going to be a times 2 squared plus b times 2 plus c equals negative 1. Now I'm going to do the same thing with that point. X is going to be 3, y is going to be 4. A times 3 squared plus B times 3 plus C equals 4. And then my third equation comes from that point. A is now 4, or sorry, X is now 4. A times 4 squared plus B times 4 plus C equals 13. And now what I do is I take the time to evaluate this and clean it up. So I've got 4A plus 2B plus C equals -1. 9A plus 3B plus C equals 4. 16A plus 4B plus C equals 13. That's the hard part. We're done. We're done with the hard part. Calculator is going to do the rest. All I need to do now is put this into a matrix. I'm going to do RREF on the calculator. It's going to give me reduced row echelon form, and I can determine what A, B, and C are easily and rewrite the equation. Okay, so matrix now. 4, 2, 1, -1, 9, 3, 1, 4, 16, 4, 1, 13. And to show you're doing RREF, you just have to do this. And then the calculator is going to spit out a nice RREF matrix, 1, 1, 0, 2, 0, 1, 0, -5, 0, 0, 1, 1. So what do we know? A is 2, B is -5, C is 1. That's not the answer to the question. The question wants the equation, all right? So now I go back and write y equals ax squared, or 2x squared, plus bx, which is -5x, plus c plus 1. There's the answer to the question. If you want to be sure you've done this correctly, it's Calc Active. Put that into y1 and check your table. And you'll notice that in your table, you will have all 3 of those points. Okay? So there's the video key for the review. There is one question that's not on this review. It's on a work session, though. I want you to make sure you know how to do. It's that the 3 interest account question. You invest money into 3 separate accounts, each earn a different interest rate. You must be able to do that question. I promise you'll see it on the exam as well. All right, guys, thanks a lot for watching. As usual, if you have any questions, don't hesitate to reach out, and we'll see you in class soon.